Hi, I'm Dustin, one of the Ozcode magicians. In this video, we're going to look at setter breakpoints and trace points. One of the most frustrating problems when debugging an issue is having properties of an object suddenly change. Previous versions of Visual Studio did not offer ways to set a breakpoint on automatic property setters, so developers would have to convert automatic properties to standard properties and manually implement the getter and setter methods. There were some other workarounds, such as creating a manual breakpoint and setting the break_at function value to the property's generated get or set method. But none of these solutions were optimal. Ozcode solves this by giving us quick and easy access to set breakpoints and trace points for setters, no matter if they're automatic properties or not, and even lets us create setter breakpoints on third-party objects. So let's see how those work. In this demo, we're going to troubleshoot a common problem when using mutable objects, which is trying to figure out why object properties change unexpectedly. In this example, we have a unit test that is setting up an order with some line items. We want to ensure the calculate total method is working correctly when none of the items are discounted. Let's run this test and see what happens. The test fails. So now we need to figure out why. Let's debug this test and see what the value of the order total is. Well, it looks like the order total has been calculated with a discount applied. But as we can see, none of the items are discounted. Before we set a breakpoint, let's first make sure it's even a problem. We'll do this by setting a trace point. A trace point will write to the output window when hit instead of breaking execution. Ozcode makes it really easy to set up breakpoints and trace points on setters. First, we need to drill down to the line items on the order object. On the isDiscounted property, clicking the magic wand will open a context menu with some options. Under the When Set menu, we have two options, one for creating breakpoint and one for a trace point. The trace point dialog lets us define the conditions of the trace point. For example, specifying the instance. The options are all instances, or specifically the instance you're currently examining. We'll choose all instances since we have multiple line items to evaluate. Next is the expression. The expression is what will be written to the output window. We can write plain text, or we can add dynamic elements such as the value of the property being set, as well as the identifier of the object instance the set operation occurred on. Now that we have a trace point set up, we can run through our code and the trace details will end up in the output window. The problem with this is that everything else ends up in the output window as well, so all of the trace information gets lost in the noise. Once again, Ozcode thought about this and gives us the trace viewer. From the Ozcode menu, select Trace Points Viewer, and anytime the trace point is hit, the output will end up in the Trace Point Viewer window, which is nicely formatted and easy to read. And we don't have to sift through the output window to find the details. Let's run the code again and see what we get. Right, it looks like there is in fact a problem. As we can see by the trace point output, somewhere there is code which is changing the value of isDiscounted, which is causing incorrect calculations. Now let's set a breakpoint on the setter for isDiscounted so we can figure out where the change is coming from. In the breakpoint setup window, we again can choose the instance, and we can also define an expression. The expression here is a conditional expression, which means the breakpoint will only be hit if the expression evaluates to true. In this case, we only want to break when isDiscounted is set to a value of true. So let's modify the auto-populated expression. Then click OK. Let's rerun this unit test again and see what we get. As expected, our breakpoint was hit. Now we can examine the call stack to see where that's coming from. Looks like we have a simple syntax error. An assignment is being made instead of a comparison. Let's fix this and see what happens. All right, the unit test passed as expected. In this video, we covered a common scenario in object-oriented programming where objects mysteriously change. With setter breakpoints and trace points, we can easily track down the offending code. In the next video, we're going to see how Ozcode takes the hassle out of dealing with exceptions. Thanks for watching.